Hey everyone, and welcome back. Today, we're diving into a brand new explainer on database administration and security. Now, this module is an absolutely pivotal part of your software engineering program. Up to this point, we've spent a lot of time focusing heavily on how to actually design and build databases from the ground up. But today we're shifting gears. We're going to look at how we manage, protect, and administer what is literally an organization's most vital resource. We need to start treating data as a corporate asset that is just absolutely crucial for a business to survive. I mean, think about it. What would happen if a massive global bank just completely lost its transaction records for, say, one single hour? The resulting chaos is exactly why mastering this topic is so critical. Okay, let's quickly glance at our agenda for today so you know exactly where we're headed. First, data as a corporate asset. Second, the DBA versus the DA. Third, database security principles. Fourth, vulnerabilities, threats, and breaches. Fifth, DBA tools and the cloud. And we'll finish up with a comprehensive lecture summary and review.
All right, let's jump right into part one, data as a corporate asset. We've got to begin with the dramatic stakes here. Why does your company's actual survival rely entirely on its data? Well, it's because an organization operates on a continuous loop, what we call the data information decision cycle. You see, users apply intelligence to raw data to produce meaningful information. Think of it like a giant engine. Your raw data might be, daily sales numbers pouring in from branches all over the country. When that raw data is analyzed, it produces actual information, like revealing that sales in a specific coastal region have just spiked by 30%. That information then becomes the knowledge that high-level managers use to make massive strategic decisions, like opening a brand new branch in that thriving region. And guess what? Those decisions trigger new actions, which generate even more data, and the whole cycle just keeps spinning. Because data is the bedrock of this entire cycle, it is unequivocally a corporate asset. Quite simply, if a company loses its database, it goes out of business. You literally can't bill your customers, you can't pay your employees, and you definitely can't manage inventory. And that makes the database administrator the ultimate guardian of this vault.
Now, before we explore how to manage this massive asset, we have to talk about a huge real-world problem, and that is dirty data. Dirty data is exactly what it sounds like, guys. It's data that is plagued with inaccuracies, inconsistencies, missing constraints, or just careless typos. And why is this so incredibly dangerous? Because if your underlying data is flawed, the information generated from it is going to be completely flawed too. Bad data leads directly to bad business decisions. It's as simple as that. So, how does data get so dirty in the first place? Well, it often boils down to a lack of strict integrity constraints. If you're learning this for the first time, an integrity constraint is basically just a strict rule in the database, like requiring an email address to actually have an @ symbol, or ensuring a date of birth cannot be set in the future. Without those guardrails, dirty data just sneaks right in. But honestly, it also comes from everyday human errors. Things like typos, the use of weird, non-standard abbreviations, or mismatched formatting when data is moved between different systems. For instance, if your sales department uses SAA for South Africa, but the shipping department uses ZAF, your database is going to completely freeze up trying to reconcile those records. We have to minimize these occurrences at all costs. To combat all this dirty data, organizations implement massive data quality initiatives. And one of the absolute most powerful tools in this arsenal is master data management, or MDM for short. We define MDM as a methodology that provides a single, unified master copy of key business entities, like a customer or an employee, across the entire organization. Imagine a scenario where the sales team calls a client John Doe Ltd., but the billing department has them entered as J. Doe Limited. That tiny mismatch causes absolute chaos when trying to track payments. MDM forces both departments to use one unified master record, ensuring uniform, consistent data across all systems. By establishing this one authoritative source of truth, MDM basically prevents the endless inconsistencies that plague large corporate networks. Moving right along to Section 2, the DBA versus the DA. Now, we know the technology is vital, but even the most perfectly crafted database system cannot operate without human assistance. And students, listen up, because this is a super common mistake people make on their exams, confusing these two distinct roles. We have the data administrator, or DA, and the database administrator, or DBA. Let's break them down. The data administrator, sometimes called the information resource manager, has a very broad managerial orientation. They focus on long-term policies and company-wide standards. They aren't tied to any specific software. They are completely DBMS independent. On the flip side, the database administrator has a narrow, highly technical orientation. They're in the trenches focusing on short-term daily operations, and they're absolute experts in a specific system like Oracle or SQL Server. Essentially, the DA sets the grand rules, and the DBA is the technical wizard who actually implements them. Though it's worth noting, if a company doesn't have a DA, the DBA usually ends up handling the whole shebang.
All right, let's dive into Section 3, Database Security Principles.
Let's talk security. How do we actually keep these databases secure from internal and external dangers? Information system security requires a massive, company-wide approach. And the foundation of this protection is built upon what is widely known in the industry as the CIA Triad: confidentiality, integrity, and availability. Oh, and we also toss in a fourth, very important pillar: regulatory compliance. Let's break each of these down right now so you fully recognize their distinctions for your upcoming assessments.
First up is the C, confidentiality. The crucial point here is ensuring data is fiercely protected against unauthorized access. And, this is key, used only for authorized purposes. In the real world, data is usually classified into levels. You've got highly restricted data, where only a handful of executives have access, confidential data for specific departments, and unrestricted public data. Protecting data from unauthorized snoopers ensures people's privacy rights are strictly maintained. And here's the kicker. Even if an authorized user accesses the data, confidentiality means they're only using it for its legitimate authorized purpose. No looking up your neighbor's salary just because you have an HR login.
Next is integrity. Integrity basically means keeping the data completely consistent, verifiable, and entirely free of errors or anomalies throughout its entire life cycle. Remember what we just discussed about dirty data? Anomalies and inconsistencies absolutely ruin the value of your corporate asset. So maintaining integrity means having rigorous data validation at every single level of the organization, ensuring that whatever goes into the database is perfectly accurate and remains untampered with. And the A stands for availability. Look, availability simply means the system must be protected from service interruptions, so authorized users can always access what they need exactly when they need it. A perfectly secure database is completely useless if the people who actually need to do their jobs can't log in because of a massive server crash or a distributed denial of service attack. And alongside the CIA Triad, we also have compliance. This ensures that all these activities meet strict external regulatory guidelines. Depending on where you live, this means adhering to strict data protection laws like GDPR in Europe or POPIA in South Africa, which heavily mandate exactly how personal information must be legally handled, stored, and secured.
Okay, moving into Section 4, vulnerabilities, threats, and breaches.
So, let's explore exactly how the CIA Triad can actually be compromised in the real world. Security doesn't just magically fail all at once. There is a very distinct chain of events. Students mix these terms up all the time, so please memorize this chronological sequence. First, we have a vulnerability. This is a weakness in the system component. Think of an employee setting their password to the word password, or a server running a wildly outdated operating system. Next, a threat is an imminent security violation. It's that specific vulnerability right on the verge of being exploited by a hacker or a nasty virus. Finally, a breach is when the threat is actually executed, and the data is officially compromised, corrupted, or stolen. So where do these vulnerabilities actually come from? They generally fall into three buckets: physical, network, and human. A physical vulnerability could literally be a stolen company laptop, which you can minimize by implementing a remote kill switch to wipe the hard drive. Network vulnerabilities include things like IP spoofing or brute force hacker attacks, which are countered by installing incredibly robust firewalls. But honestly, pay close attention to the human element. Human error is often the absolute greatest vulnerability because it completely bypasses your fancy technical defenses. It doesn't matter how strong your firewall is if an employee falls for a phishing email, shares their credentials, or just uses a blank password. Hackers prey on human psychology, which is exactly why enforcing complex password policies and continuously educating users is a massive, everyday part of a DBA's job.
Which brings us to Section 5, DBA tools and the cloud.
To actually implement all these strict security measures and manage the overall database environment, a database administrator relies on a specific arsenal of tools. First up is the data dictionary. Think of this as basically a database about the database. It tracks all the metadata, the relationships, and user access levels. Second, the DBA uses specific SQL commands, namely grant and revoke, to strictly control user access privileges, which ensures our old friend confidentiality. For example, a DBA might use a command like grant select on the employee table to the HR department to give them read-only access while completely blocking everyone else. Finally, they leverage CASE tools. That stands for Computer-Aided Systems Engineering. These tools are amazing because they automate system design by generating complex SQL code directly from visual diagrams, saving the DBA countless hours of tedious manual coding.
Now, with the massive rise of cloud computing, some people honestly thought the DBA role was going to vanish. Spoiler alert, it didn't. The cloud doesn't eliminate the DBA program at all. Rather, it just radically shifts their behavior. Instead of spending endless hours on physical hardware maintenance, software installation, and running local tape backups, the modern cloud-era DBA focuses on high-level strategic data management, tightening those security policies, and really controlling cloud computing costs, which can spiral out of control if you aren't careful. So the technical burden shifts away from the physical servers, but the managerial responsibility actually grows significantly.
And finally, Section 6, Lecture Summary and Review.
Okay, let's wrap up this explainer. Consider this slide your ultimate exam cheat sheet, summarizing the most important concepts and definitions we've learned today so you can easily recall them for your tests. First, remember our core premise. Data is a corporate asset that requires intense, careful management. To maintain data quality and prevent that dreaded dirty data, we use master data management. We also contrasted the broad, managerial DA with the narrow, highly technical DBA. We explored the CIA Triad of confidentiality, integrity, and availability. And finally, we tracked the exact chronological sequence of a security failure, going from a vulnerability to a threat to a full-blown breach. As we wrap up, I want to leave you with a bit of a provocative thought to prep you for our next topic in the software engineering program. Ask yourself, how might establishing these incredibly strict security rules, heavy encryption protocols, and complex access controls actually impact the physical performance and query speeds of the database itself? Because here's the truth. Security always comes with a cost to performance. We are going to explore exactly how to balance that delicate scale in our next explainer on performance tuning. Thank you so much for joining me today, and keep studying hard.